Hello, we're going to talk a little bit more about these error surfaces. All right, so I'm just going to go to Grant Smith error surface. Okay, and then, I'll do this intro to error surface, and I'll do open an app. Okie doke. So we've got this little piece here. So I'm just going to do is I'm just going to go ahead and delete one of these. I want to delete one of these points for a second. Okay, so now we deleted H. So I can delete this, and I can delete... yeah, I'll go ahead and delete this as well. Okie doke. So now we just have these 2 points here. Okay, so we're talking the sum of the squared errors. So, I always like to just, even if it seems obvious, it's nice to draw things. So I'll go ahead and just make a point somewhere along this x-axis, okay? And then I'm going to draw, let's see if I can get us a polygon here. Where is the polygon? Regular polygon, okay? So now I'm going to select the point, and then A, and then 4 sides. And then I'm going to select the point, and then B, and then 4 sides. Okay? And so now, what is this? This is the squared errors, right? So, this is the error. And then if you square it, you get the area of this box. So what we're trying to do is minimize the size of these boxes. So we're going to come here. So they're getting smaller, right? And then, they're going to continue. Well, now one of them is getting a little bit bigger. So now we're at the area where we're sort of trading off. And, that one looks like it might be about the best, and of course it's going to get bigger over here too. So right about here, that looks about right. And then sure enough, if I turn this back on, that minimum, the x value of that minimum is about the x value we got just by visually looking at this as well. So that's kind of a cool way to look at it, is just these, literally just drawing the squares in there. And then there's one other way we can look at this as well. So I'll just go ahead and hide these. Okay. Looks like we still got all the points on there. That's all right. Okay. Kind of want to delete them. Can we delete that? Yeah, looks like we can delete it. Okay. So there's one more thing I want to look at. So let's say the difference between our prediction minus the actual value. So the x value of C minus the x value of A. Okay, so that's one of the errors. And then we'll just go ahead and copy this, and we'll make it again, but we'll do it for B. So that's the other error, right? And if we treat the error from each point as its own dimension, now the sum of the squared errors is basically like a vector, right? So I'll just show you what I mean. So if we take this as a vector's component in one direction, so we'll just do vector, okay, and then we'll give ourselves a point. So we'll make the x value this A, and then the y value B, right, just like that, okay? And so you can see here the error here is about negative 1.8, so that's this direction. And then the error here is about negative 3.86, so that's this distance, right? So if we move C around, that's going to change the size of this vector. And I'll go ahead and and so if we're saying, all right, we want to minimize the error, one way to say that is, well, if this vector represents the error, let's minimize the size of this vector. So let's try this. What if we draw a circle here? Circle with center. So if I pick that as the center, and then let's see if I can get it to snap. Okay. So now the width of this circle, the size of that circle, is the sum of the squared errors. Kind of. It's the square root of it, but that's okay. And so if we keep coming, It's getting smaller and smaller, and now all of a sudden it's going to start getting bigger again. So again, this point here that minimizes the size of this circle is exactly that minimum point we want to find. And why is that? Because in each of these dimensions, you know, the Pythagorean theorem is this thing squared plus this thing squared, which is exactly what the sum of the squared error is, right? So you can kind of do this little dance here, so that's kind of fun. But yeah, so I just wanted to show, you know, those two other visualizations for what the sum of the squared error is, and kind of just give that geometric intuition there. So thank you for watching.